Welcome back to Backspace Academy. In this lecture on Elastic Compute Cloud, or EC2 for short, we're going to start off by looking at the different ways that you can purchase an EC2 server, and also look at the different instance types that are available and for the different applications you may use those. Then we'll look at the instance lifecycle. What happens to an instance from when it is launched, through that process, through to when it is actually terminated. We'll look at cluster networking and how we can group clusters of EC2 servers and interconnect them with high-speed networking. We'll look at the storage options that are available to attach to our EC2 instances. And finally, we'll look at the options that are available for us to connect remotely in to our EC2 server operating system. There are a number of different options that are available for us when we're purchasing EC2 servers. Up till now, we've been using on-demand instances, and they're the most easy to understand. We simply launch an instance, and from that point onwards, we're paying by the second at a flat rate for that instance. There's no upfront cost for launching it, and there's no cost when we terminate it. We just pay by the second for what we use. Now, for AWS to have capacity available for these on-demand instances, AWS needs to have a certain level of reserve capacity available to fulfill that. So if all of a sudden everyone just comes along and wants to start launching EC2 instances, there needs to be a little bit of reserve capacity available. Now, instead of having that capacity just sitting there doing nothing, what AWS does is that they have that capacity available for people to bid on. And so whoever bids with the highest price can get that capacity. And it's a little bit like eBay for reserve capacity of EC2. And that helps you to significantly reduce the cost of running instances. And it's generally the cheapest option, although not always. The reason is, if all of that capacity has been taken and the spot price goes through the roof and your maximum spot price is above an on-demand instance, then you're going to be paying a premium for that instance. So you're really putting down there a maximum price that you are willing to pay. The downside is that AWS, they can take that capacity back whenever they want, and that's called a spot instance interruption. And they can also take it back when the spot price for that next hour exceeds your maximum price. So that is something that you need to take into consideration. It's really best for batch type compute processes. For example, if you had big data stuff that need to be processed, and once it's processed, you don't need that capacity anymore. A spot instance is great for that. Now, if your spot instance is terminated or stopped by AWS, within that first instance hour, you won't be charged anything for that usage. If you terminate that instance within the first hour or any other hour after that, you're going to be charged per second, or the per nearest second, for the use of that instance. So as we mentioned before, there is a significant amount of reserve capacity available for these on-demand instances and for the variation in usage of those instances. Now, there is also a very unlikely possibility that that reserved capacity is actually used up as well by all the on-demand instances. So there are a number of other options that are available for you to reserve capacity outside of on-demand instances. The first option there is a reserved instance. Now, what that means is that if you find that you are going to be using a certain level of capacity of EC2 over the next year or 2 years or up to 3 years, you can go to AWS and say, right, I would like to have this capacity available for me for that period of time, and you can use that capacity. And by making that commitment to AWS over that period of time, you are going to get a discount on the cost of your instances. A scheduled instance is where you can purchase instances, but instead of being over a 1 year period continuously, you can have it over a 1 year period intermittently on a schedule. For example, you might use it for 1 day in a month for, I don't know, accounts processing or something like that. And so that will give you that reserved capacity that you need for that specific time of every month or week or whatever. On-demand capacity reservations are different to reserved and scheduled instances in that you're not entering into a long-term contract. These reservations are on demand. You use them when you need them, or you create a capacity reservation when you need it. When you don't need it, you just stop it, and there's no long-term contract. Now, the downside is that it is at the on-demand rate. So you might have a capacity reservation that you never use, but you will still be paying for the cost of an on-demand instance. So that needs to be taken into consideration because there is no cost benefit with a on-demand capacity reservation. But it does reserve capacity for you in the event that something goes wrong with AWS and they run out of on-demand instances that are available. You will always have an on-demand instance available for you. And finally, we have dedicated instances and dedicated hosts. With a dedicated instance, you're going to be paying by the hour for an instance that will be running on single tenant hardware. They will be hardware that only you will be using. And we also have dedicated hosts where you're going to be paying for a physical host that is fully dedicated to running your dedicated instances. Another way that you can reduce your EC2 costs is through a savings plan. That allows for reduced pricing in exchange for consistent usage in dollars per hour over a 1 or 3 year commitment. The difference between this and a reserved instance is that this is based on your historical usage in the AWS Cost Explorer. And those recommendations within the AWS Cost Explorer will be used as a basis for that saving plan. There are 2 types of savings plan. You can have a compute savings plan that will be the most flexible, and that will apply to all the different instance types, the size of the instance, the operating system, or any tenancy type. And that is going to provide up to 66% off your normal on-demand rates. The other option there is an EC2 instance savings plan, and that is applied to an individual instance family. For example, if you select an M2 type, and that is applied to a specific region as well. And that can provide up to 72% off of the on-demand rates. You can also reduce cost depending on what payment option you come up with. So if you decide to have no upfront payment and just simply pay on a monthly basis, that is one option. If you want to reduce it from that, you can go to a partial upfront cost, and that is going to reduce the price over a no upfront. Or you can do everything upfront in one payment, and that will provide you with the lowest price of your savings plan. Another thing to take into consideration is that a savings plan does not provide capacity reservations. But that said, there is nothing stopping you from including your capacity reserved instances into a savings plan. But the savings plan itself does not provide that capacity reservation. To prepare for the Cloud Practitioner exam, you will need to understand these different reserving options that are available, but it can be a little bit confusing. So having a look here, I've got the capacity reservations and the 2 different types of reserved instances. So we have reserved instances that are reserved based upon an availability zones. They're zonal reserved instances. We have regional reserved instances that are reserved within a specific region. And then finally, we have our savings plan. The first point there is the term. With a capacity reservation, there is no long-term commitment required. Whereas with the others, there is a required either a fixed 1 year or a 3 year commitment. With capacity benefits, the capacity reservations and the zonal reserved instances, they reserve capacity within a specific availability zone. But if you're going for a regional reserved instance, not a zonal reserved instance, that will not provide capacity in that availability zone. So although you're going to get the cost benefits, that capacity will not be reserved. The same again with a savings plan that does not provide a capacity reservation, but with a savings plan, you can always include as part of that savings plan a capacity reservation as well. Capacity reservations do not provide for a billing discount. But that said, you can use capacity reservations with a savings plan or as part of a regional reserved instance plan as well. So both the zonal reserved instance and the regional reserved instances and the savings plan, all of those provide for a billing discount. And finally, there are different instance limits that are applied to these different plans as well. So if you're going for a capacity reservation, that is simply going to be limited by your EC2 on-demand instance limits, which are applied per region. If you're going for a zonal reserved instance, that's going to be limited to 20 per availability zone. If it's a regional reserved instance, that will be limited to 20 per region. But both of those, if you find that you need to exceed that, you need more than 20, you can put in an application to AWS support to have that limit increase affected for you. And with a savings plan, there is no limit on the amount of instances that can be applied to that savings plan. There are a number of different instance types that are available for us to select with EC2. The first one, and the one that we've been using so far, is the general purpose types. They're great for, as the name suggests, for general purpose databases, data processing tasks, back-end servers, and the like. The next one there is compute optimized. So it's going to have a lot of compute capacity available, and that's going to be good for web servers, for batch processing, and the like. Memory optimized is great for high performance databases and for in-memory caches where we need to respond very quickly to requests instead of having to go back to a hard disk to retrieve that information. And we've got GPU or graphics processing units and accelerated computing instance types, and they're great for 3D applications, for video encoding. They're great for machine learning and AI applications as well. And finally, we've got storage optimized, which is going to be great for your big data stuff. It's going to be great for NoSQL databases, for MongoDB. It's going to be great for Elastic MapReduce, for data warehousing, anything that requires a large amount of storage. Now, with all these EC2 instance types, we have a choice of Linux and a whole heap of varieties of Linux or Windows Server. And if you want more information on those types, there is a link there to the EC2 instance types page. The instance types that we've looked at previously are running under a virtualized environment. So what that means is that the EC2 service has physical hardware, and on top of that hardware is running a hypervisor. And on top of that hypervisor are virtualized servers running on that. And so a Linux operating system is not actually running on physical hardware. It's running on a hypervisor, a virtual environment. And that goes the same whether it's Windows or Linux under EC2. EC2 bare metal instances are running on a non-virtualized environment, and the operating system is running directly on that EC2 physical hardware. It's particularly suitable for applications that benefit from deep analysis of the performance of the underlying hardware, or specialized workloads that require direct access to that physical hardware as well. There could be legacy workloads that are just not running on a virtualized environment, and you need to have the actual access to a physical environment to run it. There may also be licensing restricted applications that rely upon that physical hardware for license validation. Examples of bare metal instances are the i3, M5 metal, R5 metal and Z1D metal instance types. The T2 burstable performance instances, now they don't blow up on you, they don't explode or burst, but they're a very important instance that you need to understand. So what burstable means is that this instance will operate at what we define as a baseline performance, but it will have an ability to burst above that for a short period of time if need be. And that will be governed by what we call CPU credits. So the more CPU credits that we have available, the longer that we can burst and for the most amount that we can burst above our baseline performance. So that's great if we have demand that is not predictable. It's a bit all over the place, but we kind of know where our average for that 24-hour period is. T2 instances are great when used with an auto scaling group because when an instance is launched, it may take 15, 20, 25 minutes or whatever to go through that whole launch process that may be required. So that may be too long. And by that period of time, that burst of demand has disappeared. So the T2 burstable performance instance will fill that void and provide instantaneous response to that increased demand. Credits, they're built up over a 24-hour period. So if you stay below that baseline, you're going to build up credits for every hour that you are under that baseline. And then you can use those credits when needed to burst above that baseline capacity. And after the 24-hour period, that will be reset. Now, if you're finding that you're never having enough CPU credit balance to burst, that means that the average demand that you're getting over that period of time, that 24-hour period of time, is above what your baseline capacity that you're planned for is. So you need to consider upgrading to a larger instance to keep below that baseline capacity. Now, there's another option there called the T2 Unlimited, and that will provide that burstable high CPU availability at a flat additional rate of 5 cents per vCPU hour, and that is for as long as you need it. So instead of building up CPU credits, you just get billed for what you use. Graviton instance types, they are based upon a 64-bit ARM Neoverse core. If you've used a Raspberry Pi before, you have obviously taken advantage of an ARM Cortex core that provides very low cost, high performance. But this is an ARM Neoverse core, and the Neoverse cores are optimized for large infrastructure such as cloud infrastructure. And they will provide a very low cost and high performance compute capacity. So if you have something that is really compute intensive, and it will run on an ARM core, then by all means use that and it will provide a fantastic performance for you at a much more reasonable cost. The first generation are called the A1 instance type, and the second generation are the Graviton 2 processors, and they can provide up to 40% better price performance over the comparable current generation x86 based instances. Graviton instances are perfect for scale-out applications that can run on multiple small cores. But you need to take into consideration that not all software will run on an ARM core, but if it does, this is a great option for compute-intensive applications. If you find that you want to have a mix of different instance types and you want to have a mix of on-demand and spot instance options available, you can create an EC2 fleet of instances. And you can create an unlimited number of instance types per EC2 fleet. So you can mix and match. You can put a T2 in there with a M1, whatever. And you have the choice of mixing both on-demand instances and spot instances. So you can have a baseline capacity there, but you can also have spot instances available in that EC2 fleet as well. So it's only available through using the AWS API or one of the software development kits, or using the command line interface. You cannot do this through the console, and it's available across multiple availability zones, but not across multiple regions. So you need to create an EC2 fleet in each region if you want to have that happening in each region. And there's no additional charge for using EC2 fleet. We already know what an Amazon Machine Image is, or an AMI. We've used an AMI to launch a WordPress server, and we know that it provides the information that is required to launch that instance. And that includes a template for the root volume of that instance. For example, the operating system will have the Linux operating system. It will have the WordPress application there that will be required, that goes on that root volume. It will also have launch permissions for that AMI. So if it's a public AMI, it will have availability to all AWS accounts. If it's a private one, it will be private to that AWS account or certain AWS accounts. It will also have a block device mapping, and that will specify any volumes that are attached to that instance when it's launched. We have the AWS Marketplace, where people can put AMIs on there and sell them or give them away for free. So they can be paid, they can be free, they can be trial versions of AMIs or of software, or they could be BYO licensed software. For example, it could be an Oracle database and you bring your own license to use that. And so you can normally find a great deal of applications on that AWS Marketplace. And we've already used that before because we've used it to launch a WordPress application. There are a number of different states of an EC2 instance, depending on whether the root volume of the instance is an EBS or elastic block storage type. And we'll talk more about EBS and instant store volumes. But if you have an EBS type, you can actually stop and start those instances. But you can't do that if you have an instant store type of root volume attached to that instance. So with an EBS backed instance, you can stop it and that instance will be shut down and you're not going to be getting any more instance charges. But you will still be charged for any EBS volumes or any drives volumes that are attached to that EC2 instance. And if you stop an instance in less than 1 minute, then you're still going to be charged for that 1 minute when you restart it. There is another option, and that is stop hibernate. And again, it's only for EBS-backed volumes. And that is very good because it will suspend all of your RAM to disk. So it will save your RAM to the EBS volume. So it will allow for your instance to come back online very quickly, and it will keep all of that session data that was stored in that RAM. The other option there is that we can reboot an instance, and we can do that for either an EBS or an instant store backed volume. And that is simply an operating system reboot. And finally, we can terminate those instances when we don't need them anymore. Okay, so first off, we can use our AMI to launch an EC2 instance. While that instance is launching, it will have the state of pending. After a period of time, it will then transition to the running state after it's done all of its checks. While it's running, we have an option there to reboot the operating system. We can do that no matter what type of instance it is. It's simply an operating system reboot. If we have an EBS-backed instance and not an instant store instance, we have the opportunity there to stop that instance when we're not using it and then restart it later on. It'll go back to that pending stage and then obviously on to running again. And finally, we can issue a terminate command, and while that terminate is in process, it will be at the status of shutting down, and then it will transition to terminated after that. There are two options available for storage directly to an EC2 instance, and that's not including the external storage, for example, using an Amazon S3 bucket or using Elastic File Service. So the two options there are Elastic Block Store or Instant Store. Now the EBS is the most common type, and an EBS volume will be replicated within an availability zone, which is great. So if your drive fails, there will be another copy in another availability zone. Now the EBS volumes, if they're attached at instance launch, they will be by default deleted when that instance is terminated. Now that is the default behavior, and you can modify that by changing the delete on terminate checkbox in the console, or the delete on terminate flag if you're using the command line interface or an SDK. The EBS volumes that are attached to a running instance are not deleted by default when the instance is terminated, but they will be detached with that data intact, and you will still be getting billed for those EBS volumes, even though you won't be getting billed for that EC2 instance. But again, that behavior can be modified on the delete on terminate flag. Instant store volumes, they are physically attached to that host EC2 instance. And data is not lost when the operating system is rebooted. And that's the same for an Elastic Block Store backed EC2 instance as well. But the data will definitely be lost if there's an underlying drive failure, because we don't have any replication there. And also if the instance is terminated, that will be lost as well. So you don't rely on an instance store for any valuable long-term data. But they are good because they do provide a little bit of a performance advantage over EBS. And you cannot detach an instant store volume and attach it over to another instance. There are a number of storage options available for EBS. The first one there is the default choice and is a general purpose SSD, or it's called a GP2. The next one there is if you've got some IO intensive applications, such as a large relational database or a NoSQL database, you can use a provisioned IOPS drive, SSD as well, and that's called an IO1 drive, and that will give you high performance, consistent and low latency. The next one there or the next two are magnetic drives. So they're going to be lower cost, lower performance options. So the first one there is a cold hard disk drive, and that will provide you the lowest cost per gigabyte. It's just a standard magnetic drive. The next one there is a throughput optimized hard disk drive, and that's going to provide a low cost per gigabyte, but not as low as the cold. But it is very good for frequently accessed workloads. For example, if you had a large amount of data and you wanted low costs, but you were going to be accessing that data quite a bit, for example, for a big data warehouse. If we want to back up our EBS volumes, we can take EBS snapshots, and they are a point in time backup of that EBS volume, and they will be backed up to the Amazon S3 service. They're an incremental backup, so if you take another snapshot after that, it will be incremental, and it can be copied to other regions or other accounts to create new EBS volumes from that snapshot. We also have encryption available on EBS. We can use the AWS KMS master keys, or you can use your own customer master key for that encryption. And the data stored at rest will be encrypted, including any snapshots that are created from that encrypted drive. and also as well as data that is in transit between the EBS volume and that EC2 instance. Another feature of EC2 is that you can connect remotely to the server operating system. With an EC2 Linux server, that is done using Secure Shell, or SSH for short. And you must have a security group inbound rule on that EC2 instance that will allow SSH communication on port 22. If you're using a Mac or Linux computer to connect remotely in, you can do that just using the standard console or terminal application. If you're using a Windows computer to connect in remotely, you'll need to have an SSH or Bash client installed on that PC, and that will give you that terminal environment. It also requires you to download a PEM, which is a privacy enhanced mail private key. And you download that to your remote computer, and that is passed to the instance for authentication to that instance. EC2 Windows servers are connected remotely using the Remote Desktop Protocol, or RDP for short. The EC2 instance must have a security group inbound rule for RDP communication on port 3389. When you connect in, you use an RDP client, and that will give you a full Windows desktop environment to work out of remotely on that Windows server. And to connect, you need to download your PEM file from the management console as with the Linux server, but you also need to have an admin password for the Windows environment. EC2 Instance Connect is the easiest and safest method of connecting to an EC2 Linux instance. It operates inside the AWS Management Console, and because of that, it uses the IAM policies around your user to control access to that EC2 instance. So if you log into the AWS Management Console and you have full access to EC2, you will also gain access to the EC2 Instance Connect and be able to connect in directly to the operating system of any Linux servers that you have created or you have permissions to control. The big thing about this is that it does not require you to download a PEM file and store that remotely and then pass that over, because everything is being done inside the AWS Management Console. There is no possibility of you losing your PEM file. And so it is definitely a lot safer, and certainly the method that you should use if you want to connect directly into an EC2 instance. Okay, so that brings us to the end of the lecture, a very important one if you're going to be sitting the Cloud Practitioner exam. So make sure that you go over this and thoroughly understand this one. And I look forward to seeing you in the next one. Welcome back to Backspace Academy. Before we start the lab, make sure that you've got a copy of the Connecting to EC2 lab notes. And the section that we're going through here is Connecting to EC2 Linux. So we start off in the EC2 Management Console. I'm going to very quickly run through launching an instance because we've done this a couple of times already now. So just click on Launch Instances. We'll select the Amazon Linux 2 AMI. Please select this one because not all AMIs have been set up for EC2 Instance Connect. For example, you might get a Bitnami AMI and that may not be set up yet for EC2 Instance Connect. So just select this one here. But of course, if you wanted to run WordPress, and you wanted to have EC2 Instance Connect, you could start with this Amazon Linux 2 AMI, and then you could install, because you now have access to the operating system of Linux, you can actually install WordPress on that yourself, the same as you would do with any other server or desktop environment. So we'll just click on Select. We'll select a T2 micro because that is free tier eligible. And I'm just going to jump to review and launch because we're not going to set up anything at all. We just want to connect to this and just click on launch. Now, because we're using EC2 Instance Connect, we don't need a key pair. It's a very good safety feature that we don't need that. We don't need to download a key pair. We don't need to keep it safe anywhere. We just don't need one at all. So here we can see it's acknowledging that without a key pair, we can only connect to this instance by using EC2 Instance Connect. We'll launch instances. Whoops, I need to click on acknowledge first and launch instances. So I'm just going to let that chug away for a while. It's going to take about 5 minutes or so to go through all its status checks. I'll go away, have a cup of coffee, come back, and it should be done. Okay, so it's been about 5 or 10 minutes and our instant state is running and our status checks have all passed here. So we should be able to connect in. So I'm just going to click on this instance ID here. And now we've got this connect button here that we can connect in. So I'll just click on that. And we have a number of different options here. We've got our SSH client, and that is a way that we would have done it before the invention of EC2 Instance Connect. And we would download an SSH client on our remote computer. We don't need to do that. We just use EC2 Instance Connect and click on connect, and everything will be done in our browser through the management console. There we go. So there we have connected into our Amazon Linux 2 EC2 server, and here we have the command line for our Linux operating system. So let's type something in and see if it actually works. And there we go, it works perfectly. Let's see if we can do something a little bit more complicated. There we go. So it is completely giving us access to our Linux operating system. And this is great. So we could start off with this. We could download and install the WordPress application on here, for example, or any other application that we don't have an AMI for. We could always just install it here. So that's pretty good. So only thing to do now is really clean this all up. It's a very quick lab. So I'll just cancel out of this screen here. I'll select our instance. We'll go to instance state and we're going to terminate that instance. There we go, successfully terminated that instance. So very quick lab, but a very informative one. So you've connected into the EC2 instance and we've done some command line stuff in the Linux operating system. I hope you got a lot out of it and I look forward to seeing you in the next one. Welcome back to Backspace Academy. Before we start the lab, make sure that you've got your connecting to EC2 lab notes. And the section that we're going through is connecting to EC2 Windows. In this lab, we're going to be launching an EC2 Windows instance this time, and we're going to connect into it using RDP, or Remote Desktop Protocol. So the first thing that we need to do is go to the EC2 Management Console. And we'll launch an instance. Now we're not going to select a Linux one, we're going to search for Windows. There we go, that will do. We'll select the first one there. And we'll select the T2 micro because it's on the free tier. All we need to do now is just click on review and launch. What we need to check is that there is an inbound rule in our security group that has been automatically created that is going to allow RDP inbound on port 3389. And that has got that, so that's fine. We can launch this now. Now we need to choose an existing key pair or else create a new key pair. I've already got one here made up, but you'll probably need to create a new key pair yourself. So you go into here, give your key pair a name, and then download that key pair. I'm just going to use one that I've created previously, and launch instance. So Windows instances take quite a bit longer than Linux instances to set up. So again, I'm going to go away, have a cup of coffee, come back, and it should be done. Okay, so our status checks have all passed here. If you don't see that after a long time, just make sure that you click on the refresh button up here. We'll click on this instance ID and open it up. And now we'll try and connect to that instance. So we'll click on connect. And we need to go to RDP client because we're going to be connecting using our Windows RDP application. Now, the first thing that we need to do is that we need to get our password. So what we do is we'll click on get password. And now it's asking for our key pair. So when we created this instance at the end of the process, we created a key pair and we downloaded that key pair. So what we need to do now is upload that key pair. Okay, so I've just selected that key pair and it's put all the information here for the private key down there. And all we need to do now is decrypt our password. And what the management console will do, it will look at our private key and then it will create a password for us to connect in with. So our password decryption was successful and there is our password down there now. So now we need to download our remote desktop file. And we use that with our remote desktop application, and that will allow us to connect in remotely to this server. So we'll click on download remote desktop file. Okay, so now that we've downloaded that file, what we can do now is that we can open the Windows Remote Desktop Connection application. So we can just search for that in our Windows taskbar. So there it is there. There's also a link to installing the app if it's not already installed on your Windows installation. So this is what it should look like. And what we need to do is now open up or upload our remote desktop file to our application here on our desktop. So we just select show options and we just open and get to our RDP file. Okay, so I've opened up my RDP file and it's put in the computer, which is this AWS EC2 instance. The username is administrator. So if we connect to that, it's going to ask for that password. So we'll just click on connect and connect. And it's going to ask for that password. So I'm just going to copy and paste that in. And once I do that, a remote desktop environment will open up and it will take up the whole screen as well. So I'm just going to click on OK. And we just click on OK to accept that certificate. And that should open up. Okay, so after a little bit of time, our remote desktop environment has been set up here. And we can do anything that we would normally do. So we could right click on here and personalize it. We can change the picture at the background there. There we go. So that's how we launch an EC2 Windows instance and how we connect into that using remote desktop protocol. So I'm just going to close out of this now and clean everything up. And that will disconnect our remote session, of course. And jumping back into the EC2 management console, we'll just select that instance again. And we'll go to instance state and terminate that instance. Okay, so that brings us to the end of the lab. I hope you got a lot out of it, and I look forward to seeing you in the next one.